Hello everyone. Today we'll discuss about Spotify data analysis using Python. But before we begin, if you haven't already subscribed to our channel, please do so that you never miss an interesting video like this again. We have Avjit who will be taking this session. So without further delay, let's get started.
Spotify is a Swedish audio streaming and media services provider founded in April 2006. It is the world's largest music streaming service provider and has over 381 million monthly active users, which also includes 172 million paid subscribers. The total number of downloads on the Spotify app in the Android store exceeded 1 billion in May 2021. So millions of people listen to music all day. Even I am hooked to music. As an analyst, what's better than exploring and quantifying data about music and drawing valuable insights? Before I move ahead, I have a quiz question for you people. The name Spotify comes from a combination of two words. So which are those two words? Please let us know your thoughts in the comment section below. I would like to repeat the question again. The name Spotify comes from a combination of two words. So what are those two words? We would love to hear from you. So please put your answers in the comment section below. Now let's use Python libraries and functions to analyze and visualize our dataset. First, I'll show you the two datasets that we'll be using. So here is the first dataset that we'll be using for our demo, and then I have my second dataset called Spotify features, which is essentially about the genres of the different soundtracks. Now these datasets have been downloaded from kaggle.com. Now the links to the datasets have been provided in the description box. Please go ahead and download them. Now let me just go ahead and brief you about the columns that are present in our first dataset, which is about tracks. We have our column A, which is ID. This is the unique ID for each of the songs. Then we have the name column, which is essentially the name of the song. Then we have a column for popularity. So the popularity ranges from 0 to 100. Then we have duration in milliseconds. This is the duration of the track in milliseconds. Next, we have a column called explicit. Now we are not bothered about this column because we are not going to use it in our analysis. Then we have artist. So the name of the artist who has composed or sung the song. Then we have ID of the artist. Then we have a column for release date, which is basically the date on which the song was released. Then we have a column for danceability. So this describes how suitable a track is for dancing based on a combination of musical elements such as tempo, rhythm stability, beat, strength, and overall regularity. The value ranges between 0 and 1. Next, we have a column for energy. So the energy is a measure between 0.0 to 1.0 and represents a perceptual measure of intensity and activity. Typically, the energetic tracks feel fast, loud, and noisy. Higher the value, the more energetic is the song. Then we have a column for key. So key is the pitch, notes or scale of song that forms the basis of a song. There are 12 keys ranging from 0 to 11. Moving ahead, we have loudness. So the overall loudness of the track in decibels, it ranges from -60 to 0 decibels. Then we have mode. So songs can be classified as major and minor. 1.0 represents major or 1 represents major and 0 represents minor. Next, we have speechiness. So speechiness recognizes the presence of spoken words in a track. More exclusive speech like the recording, example talk show, audiobook, or poetry, the closer to 1.0 the attribute value. Then we have a column for acousticness. So a confidence measure of 0 to 1 of whether the track is acoustic or not. So 1.0 represents high confidence the track is acoustic. Then we have other information about instrumentalness. Then we also have a column for liveness. So liveness detects the presence of an audience in the recording. Then we have a column for valence. So valence is a measure between 0.0 to 1.0 and describes the musical positiveness conveyed by a track or a song. And finally, we have the columns for tempo and time signature. Now, even in the second dataset, we have almost the same columns, just that we have an additional column that is about the genre of the songs present in the dataset. Cool. Now let's head over to our Jupyter notebook and we'll start with our analysis. Okay, so one more thing to remember, our data has information from 1922 onwards, so all the songs from 1922 till 2021. Cool. Okay, so I'm on my Jupyter notebook, so you can see I have a few cells that have already been filled up. So we'll start with our analysis. First of all, let's go ahead and import the necessary libraries. So I'm importing NumPy, Pandas, Matplotlib and Seaborn for my analysis and visualization. I'll hit Shift Enter to import the libraries. Alright. And in the next cell, I'm going to load my dataset using the pandas read_csv function. I have my location already put here. Let me show you the location where the data files or the data sets are located. So this is my location. Under Chrome downloads, I have a folder called Spotify datasets. Okay, so let's import and check the first 5 rows in the dataset. So for that I've used the head function. There you go. So here you can see I have my first 5 rows of information from the dataset, and on the top you can see the different columns. You have ID, name, popularity, artist, then we have the release date, danceability, energy, key, loudness, liveliness or liveness, balance, tempo and other information. Cool. Now let's check for null values in the dataset. I'll just give a comment as null values. Every time when you download a dataset from an open repository, there are chances that the dataset would contain null values, so it's better to check them beforehand. So I'm going to use the isNull function present in the pandas library. PD I'm using because I had imported pandas as PD. So pd.isNull. Then I'm going to use the variable name df_tracks because I imported my dataset and stored it in the variable df_tracks. So I have my data frame under df_tracks variable, and then I'll use the sum function to check the total number of null values present in the dataset for each of the columns. If I run it, there you go. So here you can see my name column has 71 missing values or null values, and we don't have any null values for the rest of the columns. Okay. Now let's use the info method that will give us the total number of rows and columns in the dataset, and we'll also check the data types and the memory usage. So I'll say my data frame name, that is df_tracks.info. If I run it, you can see here. Now if you mark, there are total 5,86,601 names or the names of the songs present in the dataset, while the rest all have 5,86,672. So clearly there are total 71 song names or soundtracks missing from our dataset. And below you can see the data types. We have float, integer and object, and then you can see the memory usage. Cool. Now before I move ahead with our next analysis, I have another question for you. Which artist or musician has the most number of followers on Spotify? I repeat, which artist or musician has the most number of followers on Spotify? Please put your answers in the comment section below. We would be happy to hear from you. Now let's move ahead and do our first major analysis in this demo. We are going to find the 10 least popular songs present in the Spotify dataset. So I'll create a variable called sorted_df that will be equal to my data frame name, that is df_tracks dot. I'm going to use the sort_values function and say my column name is popularity. So I'm going to sort the values based on the popularity and then say ascending equal to true, since I want only the least popular songs. And then I'm going to say head of 10, which means I want the top 10 least popular songs. Now let's go ahead and print sorted underscore df. If I run it, you can see we have the list of 10 least popular songs on Spotify. You can see that popularity is 0, and you can see the names of the songs. Some of them are songs which are not in English language, and you can see the artist names as well. Cool. Now moving ahead, let's see some descriptive statistics for the numerical variables that are present in our column. So I'll say df underscore tracks dot describe, which is the function to get some descriptive statistics, and I'm going to use the transpose function after that. If I run it, there you go. So we have the statistics about count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and the maximum value for these columns like popularity, duration in milliseconds. Then we have energy, key, loudness, mode. Cool. Now if you see this popularity column, the minimum value is 0 and the maximum value is 100, and you can see the 50th percentile is 27, which is essentially the median. You have the standard deviation as 18.37. Then similarly you can check for the other features as well. Cool. Now we'll see the 10 most popular songs which are greater than 90. So we are going to check for the top 10 songs with popularity greater than 90. Let me show you how to do it. So in this cell, I'm going to create a new variable called most popular, and I'll say df underscore tracks dot. This time I'm going to use the query function that is part of pandas library again. I'll use the column that is popularity, and we'll set the condition popularity should be greater than 90. I'll give a comma and say in place equal to false, because I don't want to change my original data frame. And then I'll say sort underscore values, and I'm going to sort it based on popularity in descending order. So I'll say ascending equal to false, and then let's take only the top 10 popular songs. So I'll say most popular, use square brackets, and we'll then pass the slicing operator and say :10. Now if I run this, there you go. So here you can see the 10 most popular songs that is present in our Spotify dataset. So first we have Peaches by Justin Bieber, Daniel Caesar and Gibbon. Then we also have a song name called Driver's License, Astronaut in the Ocean, Save Your Tears. We also have The Business, Streets, and Heartbreak Anniversary. So these are the most popular songs that are present in our dataset based on their popularity. You can see Peaches has the highest popularity with 100. Alright, now moving to the next cell. So here we are going to set the index to be release date column in the main data frame. So I am setting my index using the set underscore index function. I have passed in my column name as release date, and I'm saying in place equal to true, which means I want to change it in my original data frame, and then I'm changing the value to date time format, and let's print the head of the dataset. So you can see here we have successfully changed our index. Now here you can see instead of 0, 1, 2, 3 we have the release date column and the rest of the columns are intact. Cool. Now let's move ahead. So suppose you want to check the artist at the 18th row in our dataset. You can use the index location method for that. Let me show you how to filter only specific rows of information from the dataset. I'll use my data frame df underscore tracks, and using double square brackets I'll say my column name, which is artists, and I'll use the index location method and say, let's say I want to check the artist who is present in the 18th row in my dataset. So I'll use iloc18. If I run it, the artist's name is Victor Boucher. Cool. Now let's move ahead. We are going to convert the duration in milliseconds to just seconds. So if you see our dataset, we have a column called duration in milliseconds. So all our songs are present in milliseconds. Let's convert them into just seconds. So for that, I'm using the lambda function and dividing the values in milliseconds by 1000 so that they get converted into just seconds. I have used in place equal to true, so I want to change it in my original data frame. Let's run it and do the necessary changes. Alright, now we'll print the head of the dataset just to check the duration column. So I'll say df underscore tracks dot duration dot head. If I run it, there you go. So you can see the values have now been changed to just seconds. Cool. I have the final quiz question for you. Who has the most monthly listeners on Spotify? Please put your answers in the comment section below. We'd be glad to hear from you. Now coming to the next cell. So here we are going to create our first visualization that is going to be a correlation map. We are going to drop 3 unwanted columns, and those are key, mode and explicit, and then we are going to apply Pearson correlation method. Now I have set my figure size to 14,6, and then we are using the Seaborn heatmap function to create our correlation map. I have put the variable that is correlation underscore df. You can see above we had created this, and then I'm setting annotation equal to true. So this will write the data value in each cell. I have set fmt equal to .1g. So this is a string formatting code to use when adding annotations. Then I have set my vmin and vmax. So these are the values to anchor the color map. Otherwise they are inferred from the data and other keyword arguments. CMap here stands for color map. You can just search for SNS CMap. You will get the documentation. So you can choose whichever color palette or the color map you want. Here I have used Inferno, and I have set my line widths and line color. Finally, I am giving a title to my correlation map, and I have set the extic labels. Let's go ahead and run this to get our first visualization. If I scroll down, there you go. We have got a nice correlation map. So here on the right side you can see the scale. It ranges from -1 to +1. -1 means the variables have least or negative correlation, while the values which are above 0.0 means that the variables have a positive correlation. Now here you can see there are values like -0.7 for energy and acousticness, which means if the energy is high, the acousticness is really low. Again, for loudness and say speechiness, if the song is loud, the speechiness is low, so there is negative correlation. But if you see for energy and loudness, there is really high correlation between these two variables. You can see the value is 0.8. So if the song is loud, this implies the song has really high energy and vice versa. Now if you see for a few other variables, there is negative correlation between acousticness and danceability. There is negative correlation again between valence and acousticness. Similarly, there is positive correlation between energy and valence, which is 0.4, and even for danceability and valence, there is positive correlation, which is 0.5. Cool. So from the correlation heat map, you can note that acousticness appears to have a strong negative correlation with energy. So if you see for acousticness and energy, there is a strong negative correlation, and there is a moderately strong positive relation between loudness and popularity. So if you see for popularity and loudness, the color is orange, which means it lies in this positive region. And there is also a moderately strong positive relation between danceability and valence. So if you check for danceability and valence here, there is a moderately strong positive correlation. All right. Now let's move ahead. We are going to sample our data and take just 0.4% of the total data, and we'll create two regression plots using this data. So let me first sample my data. So I'll create a sample data frame using my original data frame, which is df_tracks, and say sample. I'm going to use the int function and say 0.004 multiplied by the length of my original data frame, which is df_tracks. Alright, now let's run this and we'll print the length of my sample data frame. If I run it, you can see 0.4% of my total data set is 2346 rows. Cool. Now we are going to create a regression plot between loudness and energy. Now in our correlation map, we saw there was a positive correlation between loudness and energy, which was 0.8. Let's plot it in the form of a regression line. So I'll use plt.figure. I'll set my figure size equal to, let's say, 10,6. I'll say SNS dot regression plot. So I'm using the function called regplot, and I'll use my data as sample_df, give a comma, and say in my y-axis I'll have my column loudness, and in the x-axis we'll have energy. I'll give a color to my data variable. Let's say the color is C. Then I'll set my title to loudness versus energy. Let's say correlation. All right. Let's make sure everything is fine. Now we'll run and see our result. There you go. So you can see here clearly there is a very high positive correlation between loudness and energy. On the y-axis we have loudness, and on the x-axis we have energy, and you can see all the data points or the songs are in one direction. So if the energy increases, the loudness of the song also increases, and similarly if the loudness of the song decreases, your energy of the song or the track also decreases. So there is a very high positive correlation, and you can see the regression line here. It has gone and is increasing gradually. Cool. Now similarly, I'll just copy this code, and we are going to see another regression plot, this time for two different features. Let's say we have popularity in the y-axis. So I'll say popularity, and then in the x-axis we have, let's say, acousticness. I'll change the color to, let's say, B, which stands for blue, and will set the title to popularity versus I'll have acousticness correlation. Just scroll down and we'll run it to see the result. There you go. So I have the different points for the songs, and here you can see the regression line is downwards, which means if the acousticness of the song increases, the popularity decreases, and similarly if the popularity increases, acousticness decreases. You can see the downward trend of the regression line. Alright, now in the next cell we are going to create a new column called year from our release date column, and I have changed this to date time format. Let me just run it. Cool. Now after that, we are going to create a distribution plot to visualize the total number of songs in each year since 1922 that is available on the Spotify streaming app. So I have used my Seaborn library and dist plot function. Now one thing to remember, you need to update your Seaborn library to this version if you haven't done it. So use this command pip install --user Seaborn and the version. So here in the distribution plot we are going to plot a histogram. So I have used kind equal to hist, which stands for histogram. Let's run and see the result. Okay, so here you can see I have my distribution plot. So the plot tells us that the number of songs for each year in the dataset according to their release date have increased in the recent years since music became more accessible to people globally with technological advancements. So earlier you can see there were very few songs available in the 1920s. Later on the number of songs increased rapidly, and now you can see we have a lot more songs available for people to listen. Cool. Now we are going to see the duration of songs over the years. For that, again, we are going to create a bar plot. So I'll first create a variable called total duration equal to df underscore tracks dot, I'll use the duration column that we created with seconds, and then I'm going to set my figure dimensions. So I'll use figure underscore dims for dimensions equal to 18,7. After that, I'll have my figure axis defined. So I'll use the matplotlib subplots function, and I'll set the figure size equal to my figure dimensions, and then I'll say figure equal to sns dot I'll use the bar plot function and say my x-axis to be years, my y-axis will be total duration or total underscore dr that we created here. I'll set my axis equal to ax, and then I'll set error width equal to false. Let's set the title for my plot as title equal to year versus duration, and finally I'll say plt.xtext. I'll rotate it by, let's say, 90 degrees. Alright, let me just recheck once if everything is fine, and then we'll go ahead and run it. I have my axis, error width, title. Okay, let me just run it. We'll see the result in a moment. If I scroll down, you can see we have the bar plot for the different years and the duration of the songs in seconds in the y-axis. So earlier in the 1920s, you can see the duration of the songs were less, and later it increased around late 1930s, and this remained consistent until 2010, where the duration was high. But after 2010, you can see the duration of the songs have started decreasing. Now in the next cell, I'm going to create a line plot to analyze the average duration of the songs over the years. It is going to be similar to our bar plot, just that now we are going to visualize it in terms of a line. So I have my code ready. You can see here I've used my Seaborn library and the line plot function. In the x-axis I have years, and in the y-axis I have total duration. I've set my title to year versus duration, and I'm rotating my x labels by 60 degrees. Let's run it and we'll see the output. There you go. Now if I scroll down, you can see we have a nice line plot, and on the x-axis you have the years, and on the y-axis we have the duration. You can see that the songs from 1920s to 1960s have comparatively shorter duration, since most of the songs tended to be more singing based rather than instrument based. After 1960s, you can see the duration of the songs started increasing until, I would say, 2010, and in the present day the duration of the songs have started declining, since the attention span of the average listener is also declining. Alright, now let's move to our second data analysis project, which is based on genres of the songs. So I am importing my dataset using the pandas read_csv function. I have given my location, and here I have my dataset name followed by the extension of the type. So this is a CSV dataset. Let's go ahead and run it. Okay, now let's print the first 5 rows of the dataset. I have stored my dataset in a data frame called df_genre. I'll use the head function to get the first 5 rows of information. I'll hit shift enter to run it. There you go. You can see here I have my genre column, artist name, track ID, popularity, acousticness, duration in milliseconds again, and we have the rest of the other columns that we saw in our first dataset. Just one thing to note, here key is present in terms of C, D, E, C minor, F minor, and not in terms of numbers between 0 to 11. Now we'll see the duration of the songs for different genres. For that, I'm going to create a bar plot. So I'll start with setting the title for my plot as duration of the songs in different genres. I'll use the Seaborn library and I'll set my color palette to, let's say, rocket. I'll give a comma and say as CMap equal to true. This would be color palette. Now I'll say SNS dot bar plot. In the y-axis I'll have genre, and in the x-axis I'll have my duration column, which is in milliseconds, so duration underscore ms, and then I pass my data frame using the data argument. So I'll say data equal to df dot genre. Next we'll set the x labels, so I'll say plt dot x label. Let's say my x label is duration in milliseconds, and then I'll say plt dot y label as genres. Now let's go ahead and run this. There you go. So here you can see we have the different genres on the y-axis, and on the x-axis you have the duration in milliseconds. And if you see the graph for classical genre and for songs that belong to world genre, the duration of the songs are more compared to other genres. Now if you check for children's music genre, the duration is less or the least. Cool. And finally we'll move to our last demo, where we'll see the top 5 genres by popularity. So I'll say SNS dot set underscore style. I'll set my style to dark grid, which will be my background, and then I'll say plt dot figure. I'll set my figure size to 10,5. Then I'll create a variable called famous, since I want to take only the most popular songs based on the genre. So I have created a variable called famous, and I'll pass my data frame name, that is df underscore genre, and I'll sort the values based on my popularity column. So I'll say popularity, and I want to sort it in descending order, so I'll say ascending equal to false, and I'll take the first 10 values. I'll tell you the reason why I'm taking the first 10 values and not 5. Then I'll say SNS dot bar plot, and in the y-axis I'll have genre, in the x-axis we'll have popularity, and I'll give a comma, and using the data argument I'll say my data to be famous, which is this variable that we created, and then I'll set my title as top 5 genres by popularity. Alright. Now the reason why I took head of 10 is because there are a few genres which are repetitive. So if you see this, we have children's music appearing twice. So hence we have taken 10 instead of 5. Let me just go ahead and run it. There you go. So here if I scroll down, you can see I have my top 5 genres based on the popularity. So we have dance, pop, rap, hip hop and reggaeton. So these are the 5 genres which are most popular based on the data that we have collected from Spotify. Alright.
I hope you liked this video. If yes, please share to the maximum among your friends. We'll be back with the more interesting videos on Python. Until then, happy learning!